how exactly do the pharmaceuticals come into our water? And in addition to that, how can we prevent that?
Yeah, okay, so there's a number of routes. Probably the most important is from us using pharmaceuticals. So when we take a medicine, it comes into our body, it hopefully does the job that it's designed for, but it doesn't stay in our body. We then excrete it, so it goes down the toilet. And in Europe, what will that happen is typically that then will be transported through the sewer network to a wastewater treatment plant. Some pharmaceuticals may be removed in the wastewater treatment, but not all pharmaceuticals are removed by wastewater treatment. So what you see is coming out in the effluent from sewage treatment plants is water containing quite a complex mixture of pharmaceuticals.
Sorry, so it's us.
Yeah.
What makes the little town of Selfos so exceptional? I mean, they're so extremely ill inhabitants or what?
So, I don't think it's, I suspect they're probably quite healthy inhabitants, but actually the molecule or the substance that we see most in Selfos is paracetamol. So everyone knows about paracetamol. I guess most people in the room will have taken paracetamol. Paracetamol is actually one of the pharmaceuticals that is quite well removed by wastewater treatment. So it's a very good indicator of untreated sewage.
So it's headaches, really, in Selfos?
It's headaches,
right.
Yeah, headaches in Selfos. The other thing that we see a lot of is a molecule called metformin, which is the main treatment for type 2 diabetes. So when we do monitoring in rivers around the world, metformin is always a molecule we see a lot of.
What's the source for that?
Again, that would be the human population primarily.
I mean, what is it used in human population?
Type 2 diabetes treatment.
Sorry.
So it's a reflection of the fact that diabetes or type 2 diabetes is so prevalent globally, but also the amount of the chemical that you would take if you were a type 2 diabetic is quite a high dose each day.
Does it mean that we are overdosing, or is this just how the pharmaceuticals work?
So that's a really good point. I mean, we're here to talk about solutions. So if we go to the doctor, everyone in this room, if we went to the doctor and they prescribed us a medicine, they would probably give us a very similar dose of the medicine. Now, I'm quite heavy, so I might need a high dose, whereas someone who's perhaps lighter, perhaps better health than me, might need a lower dose. So I think, at the moment we would receive the same dose, but one of the, I think, innovative approaches moving forwards is this idea of personalized medicine, where a doctor would begin to target the dose and the pharmaceutical based on what they know about your biochemistry. And that would mean that probably we use fewer pharmaceuticals. We'd probably produce less waste pharmaceuticals. So, a lot of the time, people will go to the doctor will try a medicine, they'll find it doesn't work. They'll then give them another medicine. What that means is you've got waste, and that's another route into the environment. So, I won't ask the audience what they do with their waste medicines, but I imagine most people will throw it in the bin. And what that will typically mean is it will go to a landfill site, and then potentially it will leach from the landfill to groundwater, or be going to a treatment system and out into the environment again.